Okay, so this is like a vector equation question. So first of all, we want to find the intersection of these two equations. So to find the intersection, like if you look at r equals 1 minus 3 and 3, plus lambda 4 minus 5 and 2, then the r is like x, y, and z. So that's plus 1 minus 3 and 3, lambda 4 minus 5 and 2. So basically, if you put this into parametric form, that will be 1 plus 4 lambda, y will be minus 3 minus 5 lambda, and z will be 3 plus 2 lambda. Okay, so that means that all of these x values can be written in, the x value can be written in that form, the y value in the other form, okay, and the z value in the other form. If you look at the other equation, q, so q equals minus 167 plus lambda 2. They got this as lambda 1. Lambda 2, 1, 2, 3. So that means that the x value will be minus 1 plus lambda 2 times 1. Y value will be 6 plus 2 lambda 2. And the z value is 7 plus 3 lambda 2. So what this now means that if these have the same x value, okay, and then you can solve for lambda 1 and lambda 2, and you can actually find the point of intersection. So if you find lambda 1, you can sub it in, or you can find lambda 2, and then you sub it into the other equation, you get the actual point of intersection. Okay, so that means that 1 plus 4 lambda 1 has to equal minus 1 plus lambda 2. So just putting it all together, you get 4 lambda 1 minus lambda 2. Bring the minus 1 over, equals minus 2. That's equation 1. Okay, let's do the y's. So it's the x, it's the y's. Minus 3 minus 5 lambda 1 equals 6 plus 2 lambda 2. So putting them together, minus 5 lambda 1 minus 2 lambda 2, add the 3 to that side equals 9. Okay, so that's your second equation. Now, you could do the third equation for y, but it's actually not necessary because you only need two things. You need to find, actually just need to find, got two variables and two unknowns, so you only need two equations. You actually only need to find either lambda 1 or lambda 2 to find the point of intersection. Okay, so you got 4 lambda 1 minus lambda 2 equals minus 2, minus 5 lambda 1 minus 2 lambda 2 equals 9. So solving these simultaneously, I'm going to multiply 1 by 2. I'm going to get 8 lambda 1 minus 2 lambda 2 equals minus 4. I'm just going to change the sign because I'm going to add these two equations together. So the lambda 2's cancel. Minus 5 minus 8 is minus 13 lambda 1. And 9 plus 4 is 13. So lambda 1 is 13 divided by minus 13, which is minus 1. So now we have lambda 1. We can go back to this equation. We can even just do this parametric one here. X will equal 1 plus 4 lambda 1. So it's 1 plus 4 times minus 1, which is minus 3. The y value is minus 3 minus 5 times minus 1. Minus 3 plus 5, which is 2. And the z value is 3 plus 2 times minus 1, which is 3 minus 2, which is 1. So the point of intersection will be minus 3, 2, and 1. Okay. Now, basically, if you went on and you found lambda 2 and you put lambda 2 back into here, whatever the lambda 2 point is, you'll get exactly the same point as minus 3, 2, and 1. Because we equated these things, so those 2 points are exactly the same, so there's only one point of intersection. Okay, the next one. Show that R and Q are perpendicular. And I can actually do this one up here. Most important thing here is that you look at the directional vector. That's the only thing that determines whether it's perpendicular. So you do 4 minus 5, 2, and you dot that with 1, 2, 3, because that tells you whether they are perpendicular. 4 times minus 1 plus minus 5 times 2 plus 2 times 3. So you get 4 minus 10 plus 6, 10 minus 10, which is 0. So therefore the dot product is 0. okay, of the directional vectors. So therefore, R is perpendicular to Q. Okay, so what we want to do now is find a vector that is perpendicular to both of these vectors. Let's just copy that. I'm going to move that down here. A little bit of space to work this one out. A bit of space. And I'm just going to give myself some lines to work on. Okay, so looking at this one, so we want to find what we basically want to do. Let's look at what the question said. Move that over. So that's the equation. The question says, find a vector. So they don't say find the equation of the vector. They want an actual vector. So an actual vector would be something in the form. Now let's just call it M, N, P. Okay, so we want the actual vector, not an equation. So to get this actual vector that is going to be perpendicular to both of these lines, what we need to do is if we dot product M and P and we dot product it with 4 minus 5, 2, that will give us one equation. And then if we dot product the same thing and we do it with 1, 2, 3 with the directional vector, that will give us another statement. So that means 4m minus 5m plus 2p equals 0. And m plus 2n plus 3p equals 0. Okay, so now we have these two equations, 2n plus 3p equals 0. I'll call that 1 and 2. I'm going to times this one by 2 and this one by 5. So I can create something that's common. So that's 8m minus 10n. 8m minus 10n. Okay, and plus 4p equals 0. And 5m plus 10n plus 15p equals 0. Okay, if you get these two equations now and you add them together, you get 13m. Yeah, 13m, the 10 n's go out, plus 19p equals 0. Okay, so we've got that here. Yeah. So that's 13m equals minus 19p. Okay, so that means m is minus 19p. Okay, so now what we're going to do is something that's a little bit tricky here. We are now going to take this m equals 19n on p, and we're going to put it into both of these equations. I'm going to put it into that one, and then I'm going to put it into this one. Okay. So put it into the first one, I'm going to put it in for m, and then I'm going to put in for m there. And then I'm going to form two equations in two unknowns. There'll be an n and p, and that way I can solve for n and p. And when I get n and p, then I can find m. Okay, so it's 4 times minus 19p on 13. Sorry, that should be on 13. Minus 5n plus 2p equals 0. And this m minus 19p on 13 plus 2n plus 3p equals 0. 4 times 19 is, let's have a look at that. So 4 times 19 is 76, so it's minus 76p. And I'm going to times the 13. 5 times 13 times 13 times 13 times 13 is 65n plus 26p equals 0. So like terms, minus 76 plus 26 equals minus 50. So minus 65n minus 50p equals 0. Divide by 5. So 65 divided by 5 is 13. Minus 13n minus 10p equals 0. All right, we could then go to 13n plus 10p is 0. Okay, that's a pretty good equation. Then we get the other one. So I'm going to times this by 13 as well. So 19p plus 26n plus 39p equals 0. 39 minus 19. 20. So you get 20p plus 26n equals 0. So there's another equation. So let's put them underneath each other. 13p plus 13n plus 10p equals 0. 20p plus 26 n equals 0. We've got to put those next to the right order. 0. 26n plus 20p equals 0. Let's times the top one by 2. Gosh, what's happening there? Mm-hmm. 13L plus 19 equals that. And then n equals 78. Let n equals 78. Also, you find any equation. Okay. Oh yeah, because the point could actually be anywhere, couldn't it? But it has to follow the condition that m is minus 19p on 13. And this here is getting us nowhere, but 13n is 10p. All right, so we can actually write n equals 10p on 13. Okay, so we know we've got p. What did I do? M, N, P. So we know p would be p. N would be 10p on 13. And m is minus 19p on 13. We know the point has to be in that form. So you can let p be anything. Let's let p be 13, I reckon. That would be 19 times 13 over 10 times 13 on 13. That's a better. So the 13s will go out. So you get minus 19, 10, and then you go 13. And that is also, that would be a vector that is perpendicular. There'd actually be multiple vectors because they go through different points. If you got another p, like they said p is 78 in their solutions, that would just give you a different point. But all of them end up being in this same form. And that's when I went to solve this simultaneously. I was just going to get the same thing. You times that by 2, you get 26m plus 10p. So I'm not actually solving for n and p because there are multiple answers. So if I can get them all in terms of the one thing and then make p equal something, then it makes it easier for me to form a point.